on every single little cell that we make, every molecules are making up the cells. There are active sites and inactive sites. They're like keyholes, and you put keys in them and you can turn them. And you can unlock that gene to make it really great gene to make you really healthy, or you can turn the wrong little active site with another, because it takes another key, and it's just like, okay, we're on the path of destruction here with that. And so, I told you this protein molecule, they fold, these long string of proteins, they fold and they make all these different sites for all kinds of different keys. And if we put the right key in, then we're going to be healthy. If we put the wrong keys in, well, yeah. So
You're literally handing the keys to someone's health over to them, like through nutrition. It's so cool. Welcome to the Holistic Life Navigation Podcast, where we explore life through the lens of somatics. I'm Luis Mujica, a somatic educator who teaches people how to find safety in themselves. Your turn to learn begins now. So I'd like to welcome Karen Hurd back to the show. You are our most visited guest. So thanks for being here.
Yeah, I'm very honored to be here. Thank you.
Yeah, we get so much out of your wisdom. So it's always a thrill when I see you on the calendar. It makes me really happy. I'm going to say this one line that you and I came up with when we were talking before that made this podcast episode happen. And we're going to dive into it and we're going to see where it takes us. So the statement is epigenetics, inherited fate or habits. So you take it from there and then we'll play.
Okay. Well, I need to describe to you what happens in genetics, because if you don't have this basic understanding, then all of it's just lost and you just get confused. So everybody has inside of every cell in your body, with the exception of red blood cells and your brain cells called neurons, but every other cell, your skin cell, saliva cell, liver cell, kidney cell, any cell in your body has a complete copy of your DNA. The DNA is a computer code that tells the cell what to do. And those particular cells, like if it's a liver cell, it still contains a full copy of your DNA that's going to control what your kidneys are doing. I mean, but that's not the focus of that particular cell's job. But every single cell has a copy, except those two exceptions that I mentioned. When this cell is going to reproduce itself, it's going to die. Every cell has a certain lifespan. And when it's going to die, it will reproduce itself before it dies. It's called a mitotic event or mitosis. That DNA from that cell has to be copied. We can't lose. We got to know, how do you create a new cell? How do you do this? It has to be copied. That process is called transcription. We're going to transcribe and write down, this is how it's done. And so once the DNA is copied, then you have to make something. The DNA is there now. We have to translate it into a real functional piece of a cell, a tissue. And so that process is called translation. So now we have the instructions. Transcription's given us the DNA code, it's the instructions. Now we have to carry out the instructions. That's the translation. The instructions are telling something called mRNA. It's a messenger, another piece of nucleic type of material that will say, okay, what do I have to do? And the DNA is going to say, well, with this code, you have to run out here and I need you to get a protein, get a glycine, or get a methionine, or get a proline. We have 21 different proteins. And then those proteins are going to connect in one long, very long string. We're talking tens of thousands of these proteins that are just to make one small little enzyme or whatever we happen to be making at the moment. And then once that string is connected, it will begin to fold. And it folds according to what protein is next to it, whether it was a methionine, a glycine, or there's, like I said, 21, because each of them have different charges. There's what we call positive and negative charges, and the positive charges are contained in the center part of the atom of each of these elements, because these proteins are made out of elements. They're made out of hydrogen and carbon and oxygen and always nitrogen. Always nitrogen is is critical in a protein. It can't have a protein without nitrogen. And so it sets up a certain field, electronic field that causes attraction or things to be repelled. And that means that this long string of proteins that have been translated are all going to fold. And they fold in a very specific pattern based on the position of how many methionines or alanines or prolines or glycines or whatever it is, that because you could have 4 of them in a row, or you could have whatever the pattern is of these 21, which are the innumerable patterns that you can have. And it will fold into this molecule or into this being. After the translation is complete, you have now created whatever you are creating, an enzyme, another skin cell, whatever you're creating. After this translation is complete, and the DNA is exactly what it's a copy of it has been instructed, there can be what are called post-translational modifications. And this is where epigenetics happens. Epigenetics is outside of the basic code is there, everything is there, but the way things folded, if we inserted, there's all kinds of these post-modificational translations, ubiquitization, salicylation, glycosylation, there's all kinds of these processes. And what happens is that it can change the phenotype. A genotype is not changed, but the phenotype is how things are expressed. Okay, so the basic DNA is it's there, it's the same. But the phenotype, how it's expressing itself, can be different. Everything in our atmosphere can also impact that expression of that cell. So this is important to understand because, see, we have this idea in our head that, like, we have the BRCA gene. This is a breast cancer gene that predisposes a woman to have, it's a gene that predisposes a woman to have cancer, breast cancer. And so a lot of women get really all upset about that and say, look, I had my DNA tested. I have that gene. That doesn't mean that if you have the gene, you're going to have breast cancer. It has to be expressed in that phenotype. And what does that are these post-translational modifications.
So let's pause there.
Most of them,
because I love this. As you say that, I'm hearing the gene is like a dormant seed, right? And then, like, but depending on the environment and the conditions, either feeds that seed to grow or it stays dormant. Is that like a proper way of seeing this, or do you want to add nuance to that?
That's an excellent illustration. So the seed is still a cucumber seed or whatever it is. It is a cucumber seed, but if it doesn't have the right elements around it after it's a cucumber seed, then it can be a cucumber seed that is sort of is mutated and it grows a different way, or, you know, something happens with the cucumber. It's twisted, or, you know, whatever happened to it.
So as you're saying that, I'm kind of wondering, does that mean genetically we all have predispositions to some form of disease, and an environment, you know, like waters the seed and it grows?
Absolutely, we all do. We all do. And so it's just if it's triggered by one of these post-translational modifications. And these triggers can be your natural triggers. I mentioned 3 processes, you know, like the ubiquitization is a process, but that's naturally occurring. But when there's cigarette smoke, there's the air pollution that we breathe, there's exposure to radiation, which actually changes the DNA. So I should throw that one out altogether because it changed the actual DNA structure. But let's go back to cigarette smoking, eating lots of sugar, that changes the process because that adds the glycosylation process. So there's these different things that we take in that are bad for us that interrupt this very, very delicate balance. And so these epigenetics, things that are occurring on this molecule or cell, because it really goes down to the cell level, after it's been copied and it's been translated. So there it is, there's the cucumber seed. Those are called epigenetic changes, that we are changing the expression or the phenotype. Doesn't change the DNA. That cucumber can still produce cucumber seeds that are exactly like the cucumber seed it was before it got changed by these environmental factors.
Well, it's kind of a beautiful image you're painting. When you say that, I see this image in my mind of just these DNA, all these, like you said, instructions, which I like that idea of it. All these instructions that are embedded in all these cells. and it's instructing these cells and these expressions of our organs and our body how to essentially unfurl, like what to unfurl and do, what to not do. And I guess when we put it that way, we see, I keep hearing the word potential. It's like based on conditions, everybody has the potential to become very ill. Everybody has the potential to become very healthy. It's just really dependent on these instructions and how they're being manipulated in the right, like influenced, by the conditions.
Yes, they're influenced by the conditions. I can say, I'm trying to think of an example. I can say, I want you to go cross the street. Well, how are you crossing the street? You can run across the street. You can crawl across the street. You can try to jump across the street. You can,
Right.
There are so many different ways to cross the street. The instructions aren't cross the street. And so all the different things influence you in crossing the street, or what are our epigenetic changes.
And I as I hear that as well, I hear that, how do I say it? The instructions to me aren't like right or wrong. They're kind of like, if I imagine the instruction changing to create a tumor, let's say, like a form of cancer that's tumorous, that's a really important instruction, right? For the body to use its cells and tissues to contain cancer as a tumor. So even when the instruction goes in the way of what we would call disease, it's still the body being really intelligent and sophisticated in its desire to survive. And I like to say that out loud, just so when we see disease, we don't see it as, that's it, it's over, I'm diseased. We see it as an expression, in a healthy expression in response to the conditions, right? If that makes sense. And then when the conditions shift, it balances, and then we remediate the disease. Like, tell me your personal experience around what I'm saying.
Well, what you're saying is true. And the only thing that we have to be careful of, that there are some things where the DNA, like if you have a trisomy, that's Down syndrome, okay? So that you have certain things that are part of the DNA.
Right.
Now, we do have
right.
DNA repair systems that can go in and repair that change. And when we talk cancer, cancer is actually a change of the DNA, not just the expression, the phenotype, but it actually changed the DNA. There was harm, and so these little codons, they're little 3-membered nucleotides, they get all swapped around and whirled and messed up. So, but just because you have let's go back to the BRCA gene, that you have a gene that could predispose you to cancer, but you have to activate that gene. And so, or activate that whole process. It'll be in the post-translational modifications that it's activated, and then expresses itself as breast cancer. But it didn't have to be activated. And you could have inactivated it by the choices that you make in your lifestyle, whether it's eating or the way you live.
Yeah, and I think that's so empowering. I remember the first time I heard this, it was 2005. And the example that was used when I heard it was, they were saying something like, let's take carbohydrates, for example. And they were talking about carbohydrates from sugar can turn on, again, the expression of diabetes. Carbohydrates from broccoli could turn off the expression of diabetes. They were just using this very simple example of how these conditions like turn on and off different expressions. And I remember thinking how amazing that was, because up until that point, I grew up in a very medicalized culture where genetics were predisposed, meaning there was no way to escape it. Like, it was going to happen to you. And I think I saw people become very depressed and disempowered, and their health and their lives go downhill because they were fed this model that said, if you have this, it's a death sentence. Medicine, surgery is all you can do. And lifestyle, mental health, food, all that was thrown out the window. So I'm curious, like, how many clients have you gotten that come from that medical model feeling doomed, and then through the Bean protocol and other holistic modalities get their lives back, their health back?
Almost everyone. Because when they come to me, they're coming to me because that medical society has told them, there's nothing you can do. Your cholesterol is high because this is genetic, and because your parents had it and they had it, you're just always going to have high cholesterol. Well, that's baloney, because I have those people come to me and that's what they were told, and we're able to lower their cholesterol because we're eating the right things and we're changing this after the translation of the DNA. And that on every single little cell that we make, every molecule, molecules are making up the cells, there are they're active sites and inactive sites. They're like little, like keyholes, and you put keys in them and you can turn them. And you can unlock that gene to make it really great gene to make you really healthy, or you can turn the wrong little active site with another, because it takes another key, and it's just like, okay, we're on the path of destruction here with that. And so, I told you this protein molecule, they fold, these long string of proteins, they fold and they make all these different sites for all kinds of different keys. And if we put the right key in, then we're going to be healthy. If we put the wrong keys in, well, yeah. So
Literally handing the keys to someone's health over to them, like through nutrition. It's so cool. So I love asking you this question. I've asked you before. If you could choose three things, like what are the three categories that you would say, or the three food types or habits, whatever, that greatly impact these expressions the most from your research and from your personal work?
The number one is sugar. It's sugar. And then caffeine is right on its tail.
Tell us why. Why sugar and why caffeine? Why are they the most potent?
Well, sugar is probably the most prolific or ubiquitous. It's everywhere, and everybody is consuming sugar in vast amounts. And so sugar creates it's like a domino effect of reactions inside the human body. Okay, you eat sugar, your blood sugar goes up. When your blood sugar goes up, then you have to have a release of insulin to bring it back down, because if you don't, you go into a diabetic coma. Then you bring it down as fast as it's going up. When it's coming down so rapidly, then your body's afraid you're going to go into hypoglycemic shock, which we call insulin shock, because you had such a large release of insulin. And so then you drop so low so fast, and you feel like you have to eat sugar again, and then you go back and forth. Well, in the meantime, what happened to all the little sugar molecules, we call them glucose. Well, when that insulin was released, the insulin has to convert them into something. So it has either to shuttle it into a cell for it to be burned as energy, but with a large amount of insulin, it doesn't do it. It converts it into triacylglycerol. Well, what's a triacylglycerol do? It's a type of fat that coats all of the cell wall. So then all those little nice active sites that I was telling you about, receptor sites, they get covered up with a coating of grease. So then the insulin can't trigger the cell, because the insulin also triggers that cell to open up the gateway to let the sugar go out of the bloodstream and into the cell. So the sugar is not inside the cell, so then you don't get any energy at all. And then and then your liver goes, oh no, now we don't have enough sugar, we're going to have to make sugar, because she didn't eat sugar because she was trying not to eat sugar because she knows sugar is bad. So now we have to make sugar. Well, how do we make sugar? Well, the only way we can do that is through a process called gluconeogenesis. Well, gluconeogenesis takes one of your very precious proteins, your prolines, and all of those, and strips off that nitrogen, which I told you have to have a protein. Then you're left with carbon, hydrogen, and oxygen, which is what a carbohydrate, a sugar molecule, is made out of. Then you have an excess nitrogen floating around. It doesn't float around by itself. It's going to attract something to it. What does it attract? 3 hydrogens. Well, when you have 3 hydrogens attached to a nitrogen, you have NH3. NH3 is ammonia. Ammonia is bad. Don't ever drink ammonia. Don't breathe ammonia. You'll die. Okay, it's bad. So now we just created ammonia. So what are we going to do with that? The kidneys and the liver go, we have an ammonia molecule. So now we have to add urea to it, which is it's an OH particle. And that makes it into urea. OH is an oxygen and hydrogen, which is a negative, which pulls into this nasty piece of ammonia, and then it creates urea. Oh no, now we have a urea, so that the kidneys have to filter this out. Oh, now the kidneys are stressed. So you stress the liver, who had to go through gluconeogenesis. You stress the kidney. You also stress your pancreas, who had to produce a large amount of insulin. You also stress your pituitary gland, which is going, we got too much. We have too little. Woo, what do we do? It just creates this crisis. And I haven't even explained all the stuff with adipose tissue and the adipokines and what adipokines do, because they cause inflammation. Sugar causes inflammation. You don't believe me? Eat a bunch of sugar and you say, why are my knees sore? Why did it creak? My hips creak when I got up out of the chair. Well, welcome to the world of inflammation. Well, that came from the adipokines, which are inflammatory. Don't start me on thromboxanes, because you also increase the number of thromboxanes, which can cause inflammation too. It's just this domino effect in 1,000 different directions that
You just took me on a roller coaster ride. I was just sitting back and just traveling with you on all those loops and the sidewinders, flipping me around in my seat. But I appreciate it, because the roller coaster ride is a perfect, expression of what's happening internally. Like all those systems getting thrown off, all the adrenaline, the survival response the body goes into. It's almost like I'm hearing one survival response after another each organ and system has to go into when the balance gets thrown off so quickly from a sugar spike. The aging it does to the cell, like so many things that are occurring that I understand then would affect these instructions we're talking about.
Yep. Yep. All of this would put stress on the cell. The cell dies earlier than it needs to. It has to be reproduced. And you can only reproduce the cell so many times. There's an end cap on your DNA that says you will go through a mitosis this many times and there is no more.
So, okay. So that more than adequately explains why sugar does this. Now, so give me the short, give me like the drop version, like the there's the roller coasters and there's this rides that take you really high and drop you. What's the version of that around caffeine?
Caffeine. Now, caffeine just bypasses the sugar stimulation of the adrenal glands that had to produce the adrenaline to be able to go through gluconeogenesis. And the caffeine just drives your adrenaline straight up. And not just your adrenaline, but also accompanying hormones, including estrogen. We have hundreds, thousands of studies connecting the consumption of caffeine to increased estrogen levels. That's a hormone. You don't want to have excess hormone. If you're a male and you have excess estrogen, that's going to give you a lot of prostate problems. You're really going to be in trouble. If you're female and you have extra estrogen, now you have endometriosis. Now you have uterine fibroids. Now you have ovarian cysts. Now you have fibrocystic breast disease. Now you have infertility. It's just, the list goes on and on. Caffeine is it's bad. And then that's the second thing we're most addicted to. I mean, I'd say our society's most addicted to sugar, and then caffeine.
No, what's the third? What's number 3 with us?
Does it have to be food or can it be a substance that we use?
Anything you want.
It's perfumes and fragrances, and this includes the essential oils. Guys, it's killing us. It's absolutely killing us because we think that we have to smell like a flower or smell like whatever we think we're supposed to smell like. And it's just like, just don't smell. That means you're clean, just don't. I remember one of the neighbor boys used to come over when we were raising our kids. My kids are all grown now, but they would come over and his name was Zach. And he said, I love to come into the Hurd household. And I said, why, Zach? He says, because it doesn't smell. There's no bad smells. There's no smells. It's just no smell. It's just clean,
Just life, no chemicals, just life.
It's just love it,
Yeah, absolutely.
Yes, because now the perfumes and fragrances, they do double whammy because one, they cause you to secrete more hormones, which can create the cancers because cancers are directly affected by hormones and affects also your thinking. But they also are so tiny, these little perfume molecules, that they can it's called diffusion. They can go through your cell walls. Usually to get into a cell, it's very protected. You got to knock on the door and get permission to pass through. Well, with these things that diffuse, they're so small, they just like walk through the wall. They don't have to have permission. And then once they get into the cytocell, that's inside the cytosol, there's like this liquid surrounding all the organelles inside your cell. They will actually go to the nuclear envelope, which is another barrier, and they cross through the same way. They're so tiny through diffusion, and they cross through the nuclear barrier, and then they attach themselves to the DNA. And that alters the DNA. So now that codon, that 3-membered nucleotide, that's a certain order that tells the instruction of the cell, that's changed now. It's different. And so then the cell doesn't develop when it's copied. The transcription is carrying that damage to the DNA. So,
and everyone listening, we have an excellent episode about chemical fragrance. If you just look back, you'll be able to find it. You can just type in Karen Hurd Holistic Life Navigation Podcast, and you'll see all those, and Evan will probably put them in the episode details so you can go down there and see, well, what are they talking about fragrances? We went into it pretty deep, and it was fascinating. Well, I think we have to close. This was a short one. I think what I love the most about this conversation, and always the way you teach it's so fun, is the reminder of how much agency and direct connection we have to the shifting and transformation of our bodies. And when we hear these words about like predisposed and it's a genetic condition, it reads to many minds and bodies that there's nothing you can do about it. It's just you're a ticking time bomb, essentially. And so people opt for preventative surgeries, or they go into medication, or they go into testing every 6 months. And if they want to do that, it's their free will, go for it. And, what you teach and what I teach is your body is just relating in, again, an understandable way to the conditions it's been given and it's been inside of. When you change those conditions, a whole new relationship emerges, and it's usually a healthy one. So those expressions tend to dissolve and turn into something else. I've seen it hundreds of times in the last 15 years since I've been working with nutrition, one person after the other, my own blood working included. So thank you for bringing the information, and hopefully it will inspire people listening to get curious about their quote predisposed conditions, and get curious and say, well, what could be attributing to that, and how could I transform it a bit? Do you have any particular courses on genetics, or is it just the basic foundation course you would recommend?
No, it's the basic foundation course, but that's a good idea. I should make one just on genetics.
That'd be great. Yeah. Maybe by the time this comes out, you'll have made it. And if not, people can look for it.
Well, yeah, the foundational course would probably be the best. And you can always ask me questions too. Once you enroll in a course, you have this unlimited email contact with me. So, which
is really generous and amazing. Thank you, my friend. Always. Thank you so much. We'll have you back for sure.
All righty. Bye-bye.
That's the end of today's episode. Now let's take a moment to notice where we feel the episode in our bodies. Close your eyes. Take a breath. And let whatever wants to come up, come up. And remember, those sensations hold the wisdom that we're looking for. If you want to go deeper, visit holisticlifenavigation.com.